Last thing we're going to talk about in this unit is ways to compute things. Again, this is looking a little bit at history. Some of this is modern. In fact, if you go on Instagram or TikTok or any of those, every once in a while, some videos pop up with how people in different countries do arithmetic. There's all sorts of different methods to do things. I know that when we're in school, we learn to stack numbers in columns and go, and it seems to work pretty well, but there are other ways. So I'm just going to introduce you to two of those ways here, and we're going to look at those, and that's going to be what the day holds. So any questions that you have, just let me know. So in section 4.5, we talk about computation methods. The first one is what's called depletion and mediation. So again, this is a historic method. You probably would not use this method now, but it kind of gives you a picture of what people had to go through before there were calculators. Okay, so for instance, we are, in my first example, we are going to multiply 39 and 23. So what we're going to do is this. We are going to take our multiplication problem and we are going to create two columns. We're going to create a column for 39. I'm just going to put a little dash just to keep them separate. And then we're going to create a column for 23. On the left, and now it does not matter which column you do with either of these things too. You could do this just as well the other way, but I'm just going to stick on the left. The left is going to be the mediation column. And so what we're going to do to this number is we're going to divide this by 2, and we're going to neglect any remainders. And we're going to do that until we get down to the number 1. So just giving you a moment to write that down. And then we're going to do this together. All right, so when I divide 39 by 2, what's 39 divided by 2? What does that become? A little more. 19, it's 19.5. 39 divided by 2 is 19.5. I don't care about the point. I get rid of the remainder. So this is going to be, the next column is going to be 19. Or excuse me, the next row is going to be for 19. Then you're going to do the same thing. What's 19 divided by 2? Well, 19 divided by 2, 9 times 9 is 18. So 19 divided by 2 is going to be 9.5. Again, I don't care about the 0.5. I'm going to write a 9 right here. 9 divided by 2 is 4.5, so I'm going to write a 4. 4 divided by 2 is 2. And then finally, 2 divided by 2 is 1. You always do this until you get 1 as your last row. Everybody see where I got these values from? If you can understand this example, I'm going to put 1 or 2 of these on the test, and you're going to do the same thing, and you're going to show me your rows, and then you can check with your calculator. That's great, and make sure you got the right thing. But we've taken each of these numbers, we've divided by 2. I have ignored any remainders, so this is what I get. Now, what we're going to do on this is now for each of these rows, this determines the number of rows I have. On this one, what we're going to do is we're going to double each row. So 23 times 2 becomes 46, or 23 plus 23 is 46. 46 plus 46 becomes 92. 92 plus 92 is 184. So the premise here is that adding a number to itself does not tend to be too big of a deal. 184 and 184, let's see, that's going to be 8, and then that's going to be 16. So 368 if I've done that properly. And then one more time, 368 plus 368 is 16, and then 13, and then 7, 736. Let me double check. I'm not feeling super confident about that. Yes, okay, I feel better about it. So you're thinking, well, that's all fun and great, Berkster, but how does this help me get to the answer of what 39 times 23 is? Glad you asked. Now, here is the second to last step. What you do is you cross out any row that has an even value. Okay, so once you have halved all of these and gotten down to 1, then once you've doubled all these values, the next thing you do is you cross out any rows that have an even number to start with. And that only happens to 2 rows on this particular problem. That is the row with 4. I'm going to cross this one out. And the row with 2. I'm going to cross this one out. And the way you get the answer, hopefully, if I've done this correctly, if not, I'm stopping the video. We're going to start from the top and we'll figure it out. But the way you get your answer now is you add up all of these remaining numbers in the right-hand column. So we're going to add up the 23, the 46, the 92, and the 736. And that should give us the answer to 39 times 23. So when I do that, 3 plus 6 is 9, plus 2 is 11, plus 6 is 17. So I'm going to put a 7 right here. I'm going to carry the 1. 1 plus 2 is 3, plus 4 is 7. 7 plus 9 is 16. 16 plus 3 is 19. I carry the 1 again, and then I just got 8. And so 897 should be what our calculator tells us when you do 39 times 23. Is that what we get? Boom! Yes! So there we go. This is a historic way to multiply numbers. Before, again, we enjoy being able to stack these numbers and do their place values. That the notation that we enjoy took a lot of historical development. And so this, at some point in the past, was the way that multiplication was done. So just give you a little bit of an expanding of your perspective on what you know. So what I would like you to do, if there's a question, I definitely want you to ask it. But if you do not have a question, then what I would like you to please do is the next exercise that says, what's 56 times 27? And then feel free to verify in your calculator. On the test, I will ask for your work. I know your calculator can do this problem. Okay, so you're going to have to show me where your answer came from.
So when you're showing your answer, you have to write down
I mean, if you need to do some work on the side, this is the minimum work right here, showing me what the rows are. That's the work. Yeah. so I'm going to go through the work on this first one and see how you did. Something to note, this tends to be really the big main mistake students make if they're going to make a mistake on this, is forgetting that your first row is the numbers from the original problem. Okay, so you do start with the 56-27, which is our original problem. That should be your first row. So now divide the 56 by 2, that becomes 28. If you get a different number than me, let's talk about it. 28 divided by 2 becomes 14. 14 divided by 2 is 7. 7 divided by 2 is 3.5. I only care about the 3 portion of that. And 3 divided by 2 is 1.5. I only care about the 1 portion of that. So again, I have mediated this row. I've divided it by half each time until I get down to 1. I don't go any further than that. We good so far? Now this one, I'm going to now double each of these. So 27 plus 27 is 54. 54 plus 54 is 108. 108 plus 108 is 216. 216 plus 216 is 432. And last but not least, 432 plus 432 is 864. So there are my rows that I have to work with. And last but not least, I am going to cross out any of the rows that start with an even number. So that is the top 3. 56 is even. Everyone knows what an even number is. I'm assuming that, but I don't want to, I shouldn't, just in case. Even number ends with a number that's divisible by 2. So 0, 2, 4, 6, or 8. Anything that ends with one of those. Okay, so 56 is even, 28 is even, 14 is even. That leaves these 3 rows right here. And so I will add up these 3 values in the depletion column. So when I do that, 6 and 2 is 8. 8 and 4 is 12. I will carry the 1. 1 and 1 is 2. Plus 3 is 5. Plus 6 is 11. Carry the 1. 1 and 2 is 3. 3 and 4 is 7. 7 and 8 is 15. And I have 15, 12. That should be what we have. Is that good? Does that check out? Did anyone verify 56 times 27 turns out to be 15, 12? Great. So when you leave the test, the nice thing is this. You're going to show me this work and come up with this. When you leave the test, you should know whether you got it right or not. So you have a calculator which you can use. So you say, okay, let me double check. Make sure the work worked out right. And I don't, maybe you added something to itself. And little mistakes are easy to make, and I want you just to avoid them by checking your work. All right, I have one more of these. If you want to do another one, if you feel like you need one, always ask me, but I just have this other example. So again, I want you to use the depletion and mediation method to multiply 112 and 134. Sorry. I do not know. Some clever, probably some clever mathematician. I personally this fun how it works out.
So you can see the limitation in this is the numbers do begin to get bulky when you start to do some multiplication with bigger numbers. So that's probably at some point what caused people to decide, okay, I need to figure out a more efficient method of doing this. But for now, this is what we're practicing. So I must have had 56 on the mind when I was doing examples, because I happened to pick a number that was double 56. So remember, I cross out the even rows. So 112 is an even number, 56, 28, 14. So I just have to add up those last three lines again on this one. And as long as I did my mental arithmetic, okay, we're going to turn out fine, but you can let me know if I messed that up. So we got 12, and then that's 18. Carry the 1, and then 5, that's 13, and that turns out to be 20. Carry the 2, and then 3, 5, 10. Carry the 1, and then 3, 7, 15. So I got 15,008. That turn out okay? Awesome. Any questions about depletion mediation? Okay, well then, the other big method that we have, and then the last thing to talk about is just an application of the method. The next thing is takes us kind of to the modern day. The lattice method is a present day method of structuring multiplication that is used in different areas of the world. You may have actually seen this when you're first learning how to multiply. Some elementary school teachers like to use this as a way to introduce multiplication. What we are going to do is we're going to multiply 312 times 75. So what you're going to do is this. Let me use I don't think the red always shows up real good. We'll use that fill. What you're going to do for the lattice method is you're going to draw a rectangle. You're going to draw a rectangle with the number of columns of the first number and the number of rows of the second number. So what I mean is I'm going to draw a rectangle, and I'm going to divide that rectangle into 3 columns because of the number 312. And I'm going to divide that rectangle into 2 rows because of the number 75. So what I'm going to do is I'm going to label the outside of this rectangle. I'm going to put the 312, 312 right here. And I'm going to put the 75, 75 right here. I'll give you a minute to catch up with me on this little rectangle that I've drawn with all of my fun numbers. And you might be thinking, well, hey, that looks great, but why is this called the lattice method? Well, here's the lattice. What you're now going to do is you're going to draw a diagonal in all of these squares. You're going to start at the top right and go to the bottom left on every one of these diagonals. And so what we've done now, what you're going to see is we have now structured our multiplication. So all I have to know is how to multiply single-digit values. So it doesn't matter now what order. What I'm going to do is I'm going to multiply. So for instance, I'm going to multiply 2 times 7. It's going to go in right here. 2 times 7 is 14. I'm going to put the 1 above the lattice, the 4 below it, just like that. And then 2 times 5. 2 times 5 is 10. So I'm going to put the 1 above the lattice, the 0 below it. 1 times 7 is going to go in this one. 1 times 7 is 7. So who's clever? If this 1 times 7 is 7, what do you think I'm going to put above the lattice? A 0. Yes, a 0 above, a 7 below. 1 times 5 is 5. I put a 0 above the lattice, a 5 below. 3 times 7 is 21, so a 2 above the lattice, a 1 below, and then last but not least, 3 times 5 is 15, 1 above the lattice, 5 below. And here's how you get your answer. So this is basically just, it's the equivalent to how we learn to multiply. You've never seen this before. You're just structuring it different. So now what we're going to do is we're going to add along these diagonals. These diagonals represent the place values of the answer. So for instance, my units place, okay, which is going to be this, then my units place is 0. My tens place is going to be 4 plus 1 plus 5. I'm going to add along this diagonal. So 4 plus 1 plus 5, that's 10. So I'm going to put a 0 here, and I'm going to carry the 1. Now I'm going to add along this. This is the hundreds place. 1 plus 1 is 2. 2 plus 7 is 9. 9 plus 5 is 14. So I put a 4 here, carry the 1. And then 1 plus 1 plus 1 is 3. And then the last place is 2. And then I'm just going to take the final step of rewriting this answer so that it's not around the outside of the rectangle. So I've got 23,400 is the answer to this multiplication. That's called the lattice method. So flip the page, please. And we're just going to do a couple lattice method problems to get nice and good and confident with it. So I would like you to please do exercise 3. Multiply 427 times 83. So 427 times 83, I'm going to get started with the work. If you're still working, keep working. Don't let me rush you. Do well. And so when I plug in my values, 7 times 8 is 56. And then 7 times 3 is 21. 2 times 8 is 16. 2 times 3 is 6, so 0, 6. 4 times 8 is 32. And 4 times 3 is 12. They're just multiplication tables. I'm done. And so now what I will do is I will add up my place values. So along this diagonal, it's 1. And then here I've got 6 and 2 is 8, and 6 is 14. I'll carry the 1. And then 6 and 6 is 12, plus 2 is 14 more. I'll carry the 1. That's 2, 4, 5, and then 3. So the answer to this is 35,441. You do all right? All right, again, we're just practicing. We're building muscle memory in our brains so that when you take the test Wednesday, there's nothing new or mysterious. You're like, oh, we did like 92 of these in class. I totally remember. So go to the next one. I've increased the number of places just to make it a little more interesting. 1374 times 239.
I'm going to begin filling in my lattice here. So 4 times 2 is 0, 8. 4 times 3 is 12. 4 times 9 is 36. 7 times 2 is 14. 7 times 3 is 21. 7 times 9, that is 63. 3 times 2 is 6. 3 times 3 is 9. 3 times 9 is 27. And then 1 times 2 is 2. 1 times 3 is 3. And then 1 times 9 is 9. I think we've got that good. So now I add up. So I've got 6 as my units, 3, 6, 8 as my tens, 7, 6 is 13, 14, 15, 23. Carry the 2 up to here. So 2 and 4 is 6, 7, 8, 17, 19, 28. 3, 9, 12, and then 1 and 2 is 3, and then we have a leading 0, but we know in our number system we don't use a leading 0. That's just there because nothing carried over. And so the answer here is going to be 328,000. So ignoring that leading 0, 328,386. All right, if you have anything to talk about with that, let me know. I've got one more example of this, and so please do exercise 5. I've put a nice long number in there just to make sure that you enjoyed your class experience today. So 27,612 times 795. All right, so filling in my lattice here for 27,612 times 795. So I've got 14, I've got 18, I've got 10. There's my first column. I've got 0, 7, 0, 9, and 0, 5. 6 times 7 is 42. 6 times 9 is 54. 6 times 5 is 30. 7 times 7, 49. 7 times 9 is 63. 7 times 5 is 35. And finally, 2 times 7 is 14. 2 times 9 is 18. 2 times 5 is 10. So there's a lot of numbers, but it's just all one-digit multiplication. And now we finish. Our units are 0. 8 and 1 is 9. 5 is 14. I'll carry the 1 up to here. And then I've got 5, 6, 15. So that's a 5. Carry the 1 up to here. 2, 9, 13, 16, 21, carry the 2, 4, 9, 12, 15, carry the 1, 5, 14, 20, 28, 29, 2, 6, 10, 11, and then 2. There's my answer. So we will group this as 21,951,000. 540. So there's my answer. So we've talked about two methods. I'm going to put both these methods on the test. So I'm hoping that that's like great. I want to see that because that was nice and relaxed. So if you have any questions, don't leave with a question on your lips. So the last thing from this section is the lattice method actually formed the foundation for the earliest computation machines, things that we might call calculators. And so the first one to come up with a way to kind of store information was a mathematician named Napier. I think his first name was Charles, but I'm forgetting now in the moment. And what he did, and you can see this on the last page, you can see an illustration. He used bone because it was commonly available. And what he did is he used a bone for each of the multiplication tables. And he would just have a whole set of these, and he'd have multiples. So you can see on there, so if you're watching this on video, I'm looking at the printout on the third page, you can see on there, for instance, I'm going to go to the rectangle that has a 4 on the top. All that column is, all that bone would be, because it would be stenciled in, is that's the multiplication table for 4, right? 4 times 1 is 0, 4. 4 times 2 is 0, 8. 4 times 3 is 1, 2. So you can see an individual lattice was created for that. And that's what's happened there. And so then what Napier did is, so instead of having to draw out the lattice every time, what he would do, for instance, so we're just going to draw this. We're going to be old school since I don't have a set of Napier's bones in my possession. I wouldn't even know where to find one. So if we're going to do 7 times something like 367, here's what Napier would do, and anybody who used this, they'd go into their bag of tricks and they'd first pull out the bone that would have the 3 on it. Okay, so I'm just taking a moment to draw here. So this is the one for 3. And so that's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So he would not be drawing this. We're doing this because we don't have access to the tool. But I'm just trying to show you that this was the tool. This is the first thing. So he would have just set this rod or this bone, whatever it was scribed on, maybe they did it on wood if they didn't have stuff available, and it would say this. Okay, so the multiplication table. 15, and then 18, and then 21, and 24, and then 27. And then he would grab from his box, he'd grab the one for 6, and he would set it right next door. Okay, so what he would be doing without having to do any sort of multiplication is he would be setting up a lattice, okay, because of the uniformity of these tools. So the first actual computer that did this automatically, that was actually, I think, steam driven, if you can imagine a calculator being driven by steam, okay, way back in the day. I think that was done by Charles Babbage, and he is a great one to do for your project as you're thinking about that. Charles Babbage was interesting. And then, oh man, I'm forgetting, Charles Babbage, he apprenticed one of the first female mathematicians. I can't remember if that's Ava Lovelace or there's another popular one that that students do. Anyway, he was one of the first ones to apprentice a female mathematician. So if you're interested in historic female mathematicians that we know about, Charles Babbage was part of that story. So then 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 24, 30, 36, 42, 48, and then 9 times 6, that's not 64, that's 54. And then last but not least, he would go into his bag and he'd grab the rod for 7 and he'd put it right next door. Okay, so this is taking me more time than it would take him. He'd be done with the problem because he would just snap all these things together, and I'm just having to draw. I should probably make one with some paper. That's what a good instructor will do. Maybe someday I'll do a good one.
And then since he's taking 367 times 7, he would go down to the 7 row, 1, 2, 3, 4, 5, 6, 7, and he would just do the lattice right there. Okay, so you ignore everything else. And so 7 times 367, the units place would be 9. The next place would be 4 plus 2, that would be 6. The next place would be 4 plus 1, that would be 5. And then the last place would be 2, and it would be 2569. And he would do that without any sort of effort because he would have just placed down his materials right next to each other and been able to read the answer off. So this is the significance, and the reason why I'm even mentioning it is because it's based on this lattice method of writing down multiplication, but now it can be automatic because the information can be stored. So if you wouldn't mind, because we've got plenty of time and I'm going to take questions for the test after this. The last problem, go ahead and draw out, and you don't even have to draw the whole thing. You can just draw that row, whatever, and do 6 times 2574. It's our last problem for the day. All right, so I've drawn out the 4 different plaques that we would have, and then 1, 2, 3, 4, 5. This would be the 6th row, and then to calculate 6 times 2574, you would just go down this row. So the units is going to be 4, and then the tens is going to be 4, and then the hundreds, 4 plus 0 is 4, lots of 4s. And then the next place is going to be 3 plus 2 is 5, and then finally the 10,000s place. And we'd have 15,444. And that's how the lattice method impacted technology. And the first computer programs that actually ran, when you type things in, did something very similar to this. So